slope-intercept form to create your equation. Once you have the equation in slope-intercept form, you're going to convert it into standard form with integer coefficients written in the form ax plus by equals c. All right, let's talk through. Okay, so here are your steps. You need to first find the slope. A couple ways to find the slope. If you have your calculator programmed, under varlink, we created a slope function. So if we plug in our point, -3, 1, 4, 3, hit enter, we get our slope to be 2/7. And then we can find our y-intercept. Okay. If we find our y-intercept, we can use the slope-intercept form, y equals mx plus b, plug in a given set of coordinates for x and y, and the slope, which we just found. So let's say we use this point, 4, 3. The y-coordinate is 3. The slope is 2/7. The x-coordinate was 4. And so to find our y-intercept, we can simplify this. 2 times 4 gives you 8/7 plus b. And let's write 3 in terms of sevenths. Oops, how many sevenths is 3? If we wrote this number as a fraction of sevenths, we'd get 21/7. So that allows us now to subtract 8/7 from 21/7, and we get our y-intercept to be 13/7. So our b value is 13/7. And now you can write it in slope-intercept form. So I'm going to write that on this next slide. And so I get y is equal to 2/7 x plus 13/7. And the final step is to convert this into standard form. And to do that, you need to get rid of all your fractions. So the LCD is nice and easy. Here it is, just a 7. Distribute that through. You get 7y is equal to 2x, the 7's cancel, plus here 13, the 7's cancel. And then to move it into standard form, we'll bring the x's over. So we'll subtract a 2x from both sides. And then your final step, change the sign so that the leading coefficient is positive. So we're just going to change the sign of every single term, and you get your solution. Okay, now, can't remember if I saved it on this one or not. No. I think we created an equation for 2 points too, right? Yeah. So you could have, if you wanted to, if you had that in your calculators, you could have just entered 2 points and then put in these. It would give you this equation. It would jump right to step 3. And so then all you need to do by hand or manually rewrite it in standard form. All right, the final thing that's covered in this section is vertical and horizontal lines, the equations for those. So if you have a vertical line, what coordinate never changes? I'll come back to this in just a second. Okay, with a vertical line, what coordinate never changes? X. So the general form for a vertical line is going to be the pattern x equals a. For a horizontal line, what coordinate never changes? Y. So the general form for that is just y equals b. Now, the reason this is written as y equals b, what does the letter b represent? The y-intercept, right? Would it be true that this is the y-intercept, b, right here? Yeah. So this horizontal line still fits the pattern of a linear equation. It has the pattern y equals mx plus b. Well, what's the slope of a horizontal line? So if slope equals 0, do you even need to worry what is 0 times x? Nothing. So you can just use this equation. So a horizontal line still fits the slope-intercept form. Vertical line, however, is a vertical line a function? Can a different x, or can the same x give you different y values? Yeah, so it's not even a function. So x equals a is not going to have the form of a linear equation. It's something completely different because it's not a function. And so it's just going to be x equals that a. So very simply, if they ask you to write the equation of the vertical and horizontal lines passing through a given point, what is the vertical line that passes through this point, negative 3, 1? Vertical line fits the form x equals, and what coordinate never changes?
Negative 3.
The x coordinate never changes. So there's your vertical line. The horizontal line is going to be y equals the y coordinate 1. Pretty basic, right? Okay. So that's the only other thing that's covered in this. So you have standard form, and then you have this horizontal and vertical lines.